Okay, so in this video we're going to look at a couple more examples of simplifying radicals. What we've really done here is we're kind of combining both numbers and variables now together. We have radicals with some multiple expressions here. So here we have square root of 50 x to the fifth y to the third. So what you're going to want to do is break this apart into each of the pieces. So we work first with square root of 50. 50 is a number, so we deal with that as we deal with numbers. So remember, the idea here is we need to find a number, a perfect square, that would go into 50 that we can rewrite it as. In the case of 50, that would be 25 and 2. So we can rewrite that as square root of 25 times the square root of 2. We then take the square root of 25 because it is a perfect square, and we get 5 square roots of 2. We then move on and do the same thing with each of the other pieces. Square root of x to the fifth. Now this is a square root of something involving an exponent. So remember, we want to break that up into a power that the root 2 could actually divide into. For x to the fifth, the biggest one we can get would be x to the fourth, and then we'd have a square root of x left over. Okay, and then we can do the square root of x to the fourth by dividing. 2 goes into 4 2 times, so we get x squared, and then square root of x. The final one is the square root of y to the third. So again, we're looking for a power that the root 2 can go into because we're dividing. So we can do y squared would be the biggest one we could get, and then a square root of y left over. And then square root of y squared, 2 goes into 2 one time, so we have y on the outside, and then square root y left over. Okay, then at this point we take everything on the outside, the 5, the x squared, and the y, and put those together. Everything on the inside, the 2, the x, and the y, and put those on the inside of the square root. And now we have our answer, 5x squared y times the square root of 2xy. Okay, let's move on to our second example. Here we have a cube root of x to the 10th y to the 12th. So again, we want to do each piece. So we do cube root of x to the 10th. Remember, when we're doing a root of a power, we're really dividing. Since 3 will not go into 10, we rewrite that as cube root of x to the 9th, 9 being the biggest power up to 10 that 3 can go into. And then we'd have an x left over. And then we can do cube root of x to the 9th by dividing by 3. 3 divided by 3 would be x cubed. And then we'd have a cube root of x left over. When we come to y to the 12th, since 3 will divide into 12, we don't have to break it up. We can just go ahead and do that. 3 goes into 12 4 times. And again, take each piece on the outside, which is just the x cubed and the y to the fourth, put that together with each piece on the inside. And so we get our answer, x cubed y to the fourth times the cube root of x. Okay, and we have one last example. This is a fifth root. So again, we break it up and do each piece. So fifth root of x to the eighth. Remember, when we're doing a root of a power, we're dividing. Since 5 won't go into 8, we break it apart. So the biggest power up to 8 that 5 can go into is an x to the fifth. And we'd have 3 left over, so we'd have fifth root of x cubed. For x to the fifth, we divide. 5 into 5 goes once. So we get x, and then we have the fifth root of x cubed left over. Okay, and lastly we move to the y to the 14th. 5 won't go into 14 evenly, so we want to rewrite that. We rewrite that as fifth root of y to the 10th, 10 being the biggest power, up to 14 that 5 can go into. And then we'd have 4 left over. And then we can do fifth root of y to the 10th, 5 goes into 10 twice, so we'd have a y squared. And then the fifth root of x to the fourth is left over. And then we just put it together. We take everything that's on the outside, the x and the y squared together. Everything on the inside, we put the x cubed and the y fourth together. We get our answer, x y squared, fifth root of x cubed y to the fourth. Okay, so that's simplifying radicals of both numbers and variables. Okay, so we will continue in our next video. Until then.